and welcome to Data for Policy Fireside Chat July edition. I'm Zeynep Engin, the founding director of Data for Policy Community Interest Company and the editor-in-chief of Data and Policy Journal we publish with Cambridge University Press. As well, from our very brief conversation earlier as well, as we see, we are not just talking about abstract AI safety concepts nowadays. We are really talking about the information diet that that's increasingly shaping our decisions, our work, and our understanding of the world. We have today's guests, Dr. Ilan, Strauss, and Sruly Rosenblat from the AI Disclosures Project, who have been looking into two sides of this transparency puzzle that affect every single one of us. First question is, what if we could actually see how AI systems think through problems, their internal reasoning processes step by step? And the second question that the recent work addresses is if these systems are properly crediting the human knowledge they are built on, or are they creating what amounts to an attribution crisis that could undermine the very web ecosystem that we all depend on? So it's at this point on to Sruly first, I believe, and then Ilan to tell us more about their work. So over to you.
I'm Sruly Rosenblat. I work at the AI Disclosures Project. I am a researcher. I work with Ilan Strauss. Today I'm going to be speaking on making AI thinking more transparent through disclosure of chain of thought reasoning. Okay, so first off, what is a model's chain of thought? Chain of thought is an approach to improve a model's intelligence by using test time compute. Just basically have it run longer while it's answering the actual question. So one useful part of chain of thought is that it provides an English log of a model thought process. So this is very useful for like verification purposes for the user or developer, but it's still highly contested exactly how faithful this chain of thought is to a model's internal reasoning process. Yeah, so why is it important to disclose chain of thought? Well, number one, AI is already deployed in real-world contexts in very high-stake situations, in law, medicine, mental health, etc. Both users and developers could benefit greatly from transparency in how a decision was reached. AI companies may have incentives to hide leaps in logic or scheming that the model used in the chain of thought. So models have been shown to sometimes scheme, where they basically think of lying to the user, or they may just miss a step. But if the chain of thought isn't visible, that won't be visible to the user. Closed source models are already pretty opaque to the developer when compared to open weight counterparts, because a large part of model interpretability research is currently focused on the weights of a model. This is not something you could look at in a closed source model because we don't have access to the weights. So third parties are not able to examine the weights. So OpenAI's argument basically against sharing the chain of thought or the full chain of thought. This is quoted from their O1 release. They said that they believe that a hidden chain of thought presents a unique opportunity for monitoring models, assuming it is faithful and legible. The hidden chain of thought allows us to read the mind of the model and to understand its thought process. Yeah, so to understand exactly what they're saying, we first need to understand how chain of thought is trained. So how does the model learn to think? So originally, chain of thought was a prompting technique where you would say, let's think this step by step. And then a model would basically just think for longer before giving a final answer. But recently, chain of thought began being trained into the model using reinforcement learning. Reinforcement learning is a process where you reward a model when it gets things right and punish it when it gets things wrong. So basically, the model learns by itself what steps are important to find the correct answer. But in this case, when we're training chain of thought, only the final answer is judged. The chain of thought is only judged indirectly by how well the model did on the final answer. So the chain of thought is you answer, but it's not actually graded. Yeah, so as chain of thought provides a legible log of at least a part of the model thoughts, it is important that, so it's obviously an important interpretability tool. But a recent paper argues that this could actually be pretty fragile, and that any moderation pressure on a chain of thought during fine-tuning may hurt faithfulness. So, for example, if you were to punish a model, like deduct points on its grader, if it were to scheme in the chain of thought, or if it were to have unwanted biases, that could actually end up having the model hide its own thoughts. So it could hide it in its like weights, where it won't actually think out loud, but it will think in the background. So attempting to make the model's thoughts align could cause the model to move its thoughts to where a human can't see it. Because of this, model developers often do not want to reveal the unaligned thoughts to the developers, because while their actual responses are like they're aligned, like they're not going to say anything bad. The chain of thought isn't like that. It's deliberately not like that. So third-party developers and by extension users often do not have access to the full chain of thought. We'll get into the exact specifics later. Instead, they rely on summaries and have limited visibility when things go wrong. So so a bunch of companies actually just give you summaries of the chain of thought, and those summaries those summaries are aligned. But as LLMs are increasingly used in high-stake situations, lack of disclosure of the true chain of thought could very well do more harm than good. Yeah, so what could we do going forward? Number one, full chain of thought could be made an option with a separate moderation layer on top. So Anthropic actually kind of does this. I'll get into that shortly. But yeah, so the actual regular answers also have a moderation layer on top. Like sometimes OpenAI would just refuse to answer a question. That would be a moderation layer. So it's not trained into the model, but it would be on top of it. Companies could also just follow Anthropic's example and make the full chain of thought available and retract the dangerous thoughts while informing the user. So Anthropic, they basically they give you the full chain of thought if you ask for it. But when the model, for example, writes bad code, like code hack in its chain of thought, it would just retract that. Additionally, we could have independent third parties audit and evaluate the summaries and ensure that they meet some threshold of faithfulness. So the problem with summaries is that we don't actually know how faithful they are to the actual model's chain of thought. Even chain of thought, we're not exactly sure how faithful that is to the model's actual thinking, but this is like 2 layers of abstraction. It's not great. So if we could have independent third parties get access to the full chain of thought, as well as the summaries, they could evaluate how well those summaries actually are doing. Yeah, so as of right now, OpenAI, they only release summarized chain of thought, and even that requires government ID. Google also only does summaries. Open weight models, for example, DeepSeek, Kimi K2, these are all fully available chain of thought. And Anthropic, they release summaries, but if you ask them for it, they'll give you the full chain of thought, but they'll redact whatever paragraphs are considered bad. Reference work, our piece on chain of thought, or azimuth addendum, and in chain of thought monitorability, a new and fragile opportunity for AI safety, a piece published by multiple AI labs, Anthropic, OpenAI, talking about how chain of thought interpretability could be harmed if we were to apply moderation on the fine-tuning stage. And that is all. Thank you.
Thank you very much. So Ilan, to you now.
And yeah, it's great to be here. And thanks so much for inviting us to present. So I'm going to be talking about, Sruly spoke about kind of the model's thinking. So I'm going to be focused on the behavior of AI systems. And can we introduce greater transparency into the behavior of AI systems? Making AI's behavior more transparent. I'm Ilan Strauss, and I'm the co-director of the AI Disclosures Project, housed at the Social Science Research Council in New York, Brooklyn. You're welcome to follow up. Some of the research that we're going to present today is available on our website. And we also have a Substack. I feel like everyone has a Substack now, but we also try to write, mini substantive pieces on our Substack, so feel free to follow. So why transparency, and transparency about what? It's not about transparency with the model per se. These are AI systems which combine the model with tools and increasingly with tons of data, with tons of context. So for us, it's about transparency for healthy AI markets. these are products sold on markets, and as an economist, markets is where you measure welfare outcomes. Are prices lower? Are the quality of goods and services high? Are consumers' preferences being met? Are third-party firms being enabled and brought into the market and included, or they're being exploited? So how would the AI market would want one which is more decentralized than less centralized. So not a single firm has a stranglehold on the entire market. And that in turn relates to the AI market facilitating more open ecosystems that can interoperate, meaning that can speak to one another. And these open ecosystems should encourage value to flow to those who create it. So, for example, Google invented search, and search was a revolution for many reasons, including because it was a superior product and it helped drive traffic to third-party websites, so websites which were not Google's. And it did so through clicks. And in doing so, Google captured enormous value after developing search ads which were clickable. But Google also created and distributed enormous value to those third-party websites. So that's an example of Google as a platform allocating value in its early years to these third-party sites through clicks. And then another aspect of healthy AI markets is that there's competitive markets, or as I'll get into, at least if it's not that competitive, a dominant firm has their power checked by some sort of institution. So that's why we want transparency in the first place. And I'm going to be focusing on information. And I think this actually ties in quite well to what Zeynep said in the beginning, and where she spoke about our information diet. Because obviously AI is an informational tool. It's saving us time and cognition, and it's producing information. But more generally, drawing on the tradition of Herbert Simon, especially, and Joseph Stiglitz and many economists, information is power. And information can be used to exploit consumers. And I was wondering, because economists actually have papers where they assume price is random. So imagine you went to buy your coffee and they didn't tell you the price of the coffee. They just said the price of the coffee is going to be random. And so you don't know how much you're even going to be paying for the price of coffee. So in some ways, as a consumer, you'd be exploited there because you don't know how much you're going to pay for the price of coffee. And that reminds me of the rules which were passed, which say that online platforms have to show the total price that the consumer pays. So until recently, Airbnb and other platforms didn't have to even show you the total price of the good or service you were paying for until the final screen, by which time the user was substantially locked in. So this is a bit slightly more different. This is about a random price of distribution. Imagine not knowing the quality of a product. Well, that happens all the time, right? And then consumers land up getting exploited. And that's why historically something was invented called brands, which allowed consumers to develop trust. And it's also why you have consumer protection acts, which ensure that consumers can return goods which are faulty, so then consumers don't withdraw from the market. And that's also why we rely on algorithms initially to help us search millions of goods and services. Imagine not knowing the best product to buy from millions. Well, that's why Amazon invented product reviews in a revolutionary move, even if it meant the reviews were bad. Imagine not knowing imagine knowing what a consumer is addicted to, what power that information would give a company. And that's why these online ad companies are so profitable. Imagine knowing what products are selling well out of all of the products being sold in America. Well, Amazon has live data on all the products which are doing well on its platform, which it can use to decide which markets it wants to enter into itself. So it can even know the profit margins, potentially, and then it can decide what brand it wants to replicate as its own in-house brand. And then imagine indexing the entire internet, meaning every website which is out there and you have a brief description on it. And that's what Google search did, right? It indexed and crawled the entire internet. And now it's using that to its own advantage substantially when it creates AI overviews. So information is power, and information is especially power in digital markets. And Herbert Simon, basically foreseeing this, said that any tool which allows us to manage information is going to get incredibly powerful. And he said any tool which is going to allow us to manage the abundance of information. But we could say that, thinking about AI more generally, algorithmic tools for managing information, they hold power when time or cognition is scarce, and we know our time and cognition is scarce. Even though economists like to assume that users are, rational, not constrained by time or cognition, they can choose between millions of products, they can write 1 million research papers a day. We know that's not the case. Clearly, they are constrained or bounded. So time is scarce, information is abundant. There's millions and millions of different websites that we want to read, but we don't have the time to. Millions of books we want to read, and information is also quite complex. So we need help of making sense of reality. We hire research assistants. We co-author papers. So today, algorithms manage information online substantially for search and recommendation. Information is too abundant to just provide it's as something that you scroll through manually. That's not how platforms make their money, and that's also not how platforms provide utility. They provide a list of the most relevant personalized piece of information. And AI systems now produce information, generative AI, and it's information, importantly, that's tailored to you based on increasingly the memory that the AI has and all available context, the user's data, the broader project data, and the data they have about your macro environment, where in the world you are, what is your possible age. So it uses those signals to produce relevant information for you, which is personalized. And here's just an idea I was toying with, and this makes my presentation a bit less linear. So I apologize about that. But I want to introduce the concept of countervailing power. And countervailing power is a concept which comes from John Kenneth Galbraith's American Capitalism, which I think is 1952, near check. It's a really well-written book, and it had a big impact at the time. And Galbraith was basically saying that we often think of the solutions to problems in markets as being about more competition. And more competition is the natural check. So the way to ensure that OpenAI doesn't abuse its power of its models and our reliance on it for information is to encourage more competition from Anthropic, from lots of small startups. But Galbraith says that's pretty unrealistic because companies have become so large and the barriers to entry in markets have grown. We all know how much it is to run an AI system today. These companies run at enormous losses. Right? They're losing billions and billions of dollars and having to constantly fundraise. So more competition may be unrealistic. So Galbraith instead suggested the concept of countervailing power, which is when a really big company meets an institution on the other side of the market, not the same side, another firm on the other side. So for example, a trade union is a countervailing power against a firm's monopsony power in its input markets, whereby it can purchase labor power and pay a wage below the marginal productivity of labor. So trade unions are countervailing power. So I wonder if we shouldn't apply this to digital markets, because digital markets have very high barriers to entry, and it seems like firms are not going to get small or smaller anytime soon. Before we had network effects. Now we have what economists call economies of scale with very high fixed costs. So to compete, you require lots of money. So I wonder, can information in particular, can we use information to help build countervailing power or not? And I don't provide an answer in this talk, but I suspect we need some sort of, we need to use information to build countervailing power in digital markets. So the traditional example is that if you have a buyer, you have a countervailing power by having sellers grouped together to counteract the power of that dominant buyer. So what's an example of a dominant buyer in AI? Well, it could be OpenAI, or it could be Google when they index and search the web, and they're effectively taking instead of buying content, right? And buyers historically have done that all the time, right? When they could take inputs into production, they do, whether it's land or oil or labor power as slavery. So the question is, can sellers unite to form a countervailing power in the world of content bargaining, right? So that would be if you have a marketplace for content, which AI providers have to buy content from which they consume, either in training their models or in inference when the model provides an answer. And in my example later, we're going to focus on inference. So that'd be a countervailing power institution. And then the question is, what information do we need to make that countervailing power institution real? Just like you have ad markets online, where it's traded on exchanges, kind of like a stock exchange. So, that runs in information and bidding. So what information is needed to create this countervailing power institution, to OpenAI's power in content markets? And Galbraith noted that a key way that big institutions, big companies escape the reach of countervailing power is through vertical integration, which is when you basically own all the companies you deal with and all the companies you're going to purchase your inputs from, and it's vertical. So you're also going to own companies in adjacent industries. So, for example, that would be the equivalent of OpenAI buying cloud providers, buying websites, buying libraries to scan books, buying publishing houses, which is what these companies have been looking to do. And I was trying to think, what are examples of countervailing power online which use information? And I only thought for a minute, and I think the people here would probably come up with some really good examples. But I was thinking, okay, an ad blocker, that's a pretty powerful kind of countervailing power, and that comes through the user agent, the browser. And here you have an example where the browser is allowing the preferences of the user agent to trump the preferences of any one website. So the browser is facilitating that the consumer, the user, is king there, and it's their needs that matter over any website's needs. And is that informational? Well, yes, it's going to rely on different information stacks and protocols, right? HTTP and whatever the ad tokens is sending, maybe even based on cookies. I need to Google what an ad blocker relies on to work, but it's going to rely fundamentally on information and different parts of the informational stack, which created the World Wide Web. And then what about a bot blocker? So Cloudflare, who runs these DNSs and is part of this middle layer policing the internet, making sure we're safe and secure, they released this tool whereby websites can now block AI bots from scraping them and indexing them and using their content without their permission. Now, this might not be a perfect solution, but again, what kind of information does that rely on? Well, it relies on Cloudflare's unique position in the market and the unique information it has, which other actors are not privy to. They don't have the sorts of infrastructure and the sorts of information that Cloudflare has. And there Cloudflare is acting as kind of this countervailing power, you could argue. And then I'm thinking about all the protocols which force interoperability on markets, including the AI market. And we just have a piece out today actually discussing Anthropic's Model Context Protocol, which tries to force interoperability between AI applications and tools and data on the internet. So to allow any AI application, for example, to access Slack or Gmail. So that interoperability through a protocol, again, is fundamentally a data layer, right? Because it's about communication. So this is kind of just something which I'm trying to test out. And then just a practical example of what we're seeing happen by way of model behavior online, which requires transparency to police, because that's kind of the title of the talk, right? So what behavior are we seeing? How do we make it more transparent? So here's an example of some behavior which we might want to make more transparent through some kind of backend informational markup system. And this is the fact that web-enabled large language models, they answer queries increasingly using the internet, right? The internet's become the brain of these models because they want up-to-date information, they want highly credible sources, they want more detailed answers, but they don't always credit the web pages that they consume, not just visit, but consume as the key relevant informational sources, putting aside hallucinations and other complications. So this creates what we call an attribution gap. And so our paper, which is in the hyperlink, tries to estimate that this attribution gap, which is the difference between the URLs actively read and consumed by large language models before they answer your question and those that they actually cite. So maybe they consume 10 websites as essential knowledge sources, but they only cite 3. Then the attribution gap would be 10 minus 3 is 7. Now, how are we able to do this? Well, firstly, Sruly helped with this data set substantially, but the data set had logs. So these companies are actually publishing the logs, even though they're often highly sanitized logs of the behavior of these models, what these models are doing online, which are the websites that they're visiting. So already you can see that the decision by these dominant integrated model developers like ChatGPT, like OpenAI, like Anthropic. So their decision to at least give us some of the logs showing the behavior, tracking the informational breadcrumbs that this model lays as it tries to answer a question, that is important in understanding the behavior of these models and seeing if that is good or bad behavior. And then on the basis of that, seeing what needs to be done. So in our findings, we run a bunch of statistical models, and we find that the average query answered by Gemini or Sonar, it's going to go to the internet. Some might not, but on average, around 3 relevant websites go uncited relative to the websites which they visit to consume information to answer the question. And ChatGPT, we look at 4.0, it's got a very small attribution gap. Now we find this is probably because they're cleaning up their logs beforehand to make sure everything looks nice and neat, such that, oh, the model didn't visit more websites than it cited. And make sure that the log, if the ChatGPT is only citing 5 URLs in its output, that its log is only going to contain 5 websites. So it tries to neatly align these things. And then we also look at citation efficiency in a different regression, which is to say, well, how many extra citations in the answer, URLs, does the model provide for each additional website it visits? And we find, and we look at identical queries, and we find this large variation in the citation efficiency of these models. And we find that the model design has a big impact. The nature of its thinking, is it using, is it a local model that tries to use, GPS and provide local, use more local URLs on the base of your GPS? So the model design already has an impact on the extent to which these models are exploiting the content creator ecosystem versus, engaging in proper attribution practices. So that really matters. And by the way, what I should have added on the slide is that this is based on an Ella Marina data set, which had several thousand conversations. So I should have put that in. And then just so that's an example, and you can see you can visit the URL and go to the link, and that's an example of, well, the log is important in providing transparency on the behavior of these models. And so let's just extend this idea of logs and say, the data layers are vital for providing, I would argue, a basis for building countervailing power online. And by data layers, I mean observability layer. That's usually what people talk about when they talk about monitoring the behavior of something online, the observability layer. And that consists of logs, traces, and metrics. But then what about protocols? And protocol is something deeper that sits beneath that. But protocols as rules of the road, as Tim O'Reilly, my co-director, tries to frame them as these rules of the road, they do shape behavior online because they shape interoperability. and they shape what sorts of data communication needs to be made explicit and codified as a set of rules governing communication online. So that also, in creating these rules, it can create a set of norms for behavior, for when different systems need to interoperate and talk to each other and when they don't have to. So can these two layers create an informational basis for countervailing power? And again, we're looking at harms in the market, in how these models are deployed. Our emphasis isn't on saying, let's make the model, this black box, more transparent. No, there's some benefits to saying, let's focus on the model because it's upstream. But the reality is that the behavior of these models, when, for example, it's searching the web, is not just reliant on the model, but it's reliant on increasingly, tools and symbolic tools, and it's relying on outside data sources. And so to understand the harms, one cannot look at the model in isolation. One has to look at how the model behaves when it's given a set of tools like internet search and indexing and a set of data sets. Now, I just want to briefly dig into, and then I'm going to conclude. I know I've been talking for too long. Sorry, some of this observability layers. And in a blog post, we look at one example, and that's a trace. And a trace basically, shows you the steps, the steps of actions that the model had to take in order to kind of, achieve a given outcome. Where each of those mini steps, these little kind of sub arrows, are called spans. So this is just an example which Claude generated for me, and which definitely needs refining. And it's an example trace showing what happens when you ask ChatGPT a question, and then it goes and searches the internet to try to answer that question. So here it's breaking it down into the different steps, and this is like only maybe 1/5 of the size of what that trace would be. But you can see that the trace has important information, not all of which will be revealed to the developer through the API or to the consumer through the front end. And part of the trace will also show, how relevant was this website. That's commonly what they're going to have in the back end. So that, for example, is a piece of information that you could use to create countervailing power, because, if ChatGPT visits a website and says, eventually this is like very relevant, this website, to me answering your question, and I'm going to consume all that information before I answer your question, then chances are that website needs some sort of, remuneration, either through attention or monetary. But you first need that piece of information from the trace showing that this website is more relevant than the other. And so these kind of informational seeds are in the trace. And so the question is, can this be a basis for accountability, monitoring, and mutually beneficial monetization in AI markets? We think it can. And yeah, this is just, as you can tell, a very early area of research, and we welcome input on it. Thanks very much.
Thank you. Thanks very much for fascinating sort of arguments there. I'm curious about what questions this raises in the audience here we have online. Perhaps, I saw John making some comments.
Well, one of them is just a pointer to an actual paper, which is a very recent work from Maturing on augmenting lean language models. So it's just a reference to support what Ilan was talking about right at the end there. So it's just if people want to see recent work on that. The other was just a comment on the rather weird situation where we have a market failure. It's incomprehensible that people continue to invest in OpenAI at the rate of loss they're making, because there is literally no way that the energy consumption model they have can sustain long enough. There isn't a way to increase electricity grid supply in any developed country, and there certainly isn't anything near sufficient electricity in the global south to sustain the data center needs they have. The fastest country in the world at building nuclear power stations is China, and their minimum time to build is 6 years. In most of Europe, in North America, it's 10 years. So if you start today to meet the needs of data centers that are needed within the next 2 years, you'll be 8 years late. And the idea that somebody would go on investing in a company like OpenAI at the rate of burn for 8 years without actually seeing any money doesn't make any sense. So I'm mystified. When you look at the optimizations that are going on in the existing companies, I mean, look at Google Gemini, then they've done an awful lot of work in the last 8 years since they started on attention. So they're significantly better in that space. I mean, look at the open models that are coming out like Llama 4, they are significantly better. But when you look at chain of thought or chain of reasoning or any of these sort of, these various different words that are used, I think classic bit of the hype in LLMs that are misusing the English language to describe these things. They're not thought. They are, as Israel described, they are reinforcement learning mechanisms to refine alignment filters after the event, after the large language model was trained. So they're effectively a sort of shim or a thin layer or a sort of wafer thin layer that fixes up problems after the event. It doesn't go back and alter all the weights in the underlying model. These are increasing the cost of using the system because you effectively iterate over all the aligning, so they don't solve the problem of the vast energy and water consumption that these models use. So they make it worse, although superficially they improve the quality of the output. They do many times reduce the level of hallucination. But actually, what we need is sort of fundamental shift in this space. I think these talks were great in kind of nailing this, because for me it's hard to see how we deal with this without actually going back to opening up the models and actually addressing explainability within the models. And to do that at the scale the models are running, even the leaner models, even Llama 4, which is pretty good actually in terms of scalability. The adding explainability to these is a vast increase in their cost. So somebody has to come out with a completely new approach there. And I think without it, these are basically inapplicable in anything where there are safety implications from the outputs. There simply is no way, for example, an insurance company could underwrite any of the risks associated with these systems because they can't quantify them. And if you can't quantify the risk, then you won't insure. So this rules out the use of this technology in healthcare, defense, and finance. So what's left is effectively entertainment. But that's about it, I think. Anyway, that's what I just wanted to say. But my comment in the chat was really just sort of trying to say that if you're an investor, you might want to place a bet against these people. So I was saying you can start thinking about shorting them, because at some point this would be a good way to make a lot of money. I'm not an investor, so I'm not quite sure when the best day, month, or year to do that would be. So maybe somebody else here has a good idea, and that might be good for you, I say. But thanks for the
You can
talk.
ask OpenAI.
But really good stuff. Thanks.
No, I mean, sustainability is obviously important, and there's a lot of people who say this paradigm is not sustainable for many reasons. And I mean, many people are saying that the upper limit on the development is going to be the energy consumption, which is something, that I haven't looked into in any detail, but clearly it's, the US government, for example, is very concerned by the cap provided by its energy supply on further model developments. So clearly, more energy efficient paradigms are essential. And I know many people like Jan LeCun say the current paradigm is bust anyway.
How do you actually measure the? Well, you mentioned that you found out like 3 references are missing for each one. So you gave some numbers basically like that. How do you methodologically go about finding out what's not being referenced in a large language model output?
That's a good question. I also see Alan has a hand. Should we take his question too, and then myself and Sruly can try and answer both?
Well, I was actually trying to clarify whether you've got a human in the loop view on how you mitigate the risk of bad answers. You say you can discover bad answers, but is the only route to filtering those human in the loop, or is there an automation of what you do about the bad answer?
My personal view is that at least a human should be able to see what's happening. There may be automated solutions, but that could still, like, a developer is still a human, right? A third-party developer. If they're finding those solutions, they're gonna need a chain of thought either way. So whether it's human or AI or any type of solution, there's disclosure is still very important with regards to finding the difference between the logs and the cited materials. So actually what we were doing was measuring the difference between the websites that the AI companies say they visited, like they return it as in their API response, and the in-text citations, which is what the human would see. So we don't actually know whether they're listing out everything that they visited, but we do know that from what they list out, these are the citation gaps.
Yeah, exactly. So we're using the logs. But again, some of the logs can be pre-filtered. So it looks like OpenAI pre-filtering the logs. And these are the logs from the conversation. And this is the log you're going to get, if you kind of accessing the model or asking it questions via the API, right, Sruly? The log is going to show some of the websites the model visited. In some models, more websites and some less. And so we can't be certain if the more or less is due to it pre-filtering the log or just because it just visited fewer websites potentially. And then the output is showing citations, right? Just like the user would see like a bunch of citations, and then the different models cite differently, So Anthropic and Gemini, right, Sruly, they use like numbers in little square brackets whenever it's citing a URL. So it'd be like 1 website, 2 website, whereas OpenAI has a slightly different citation system, and that's in the conversation. So it comes through the API, we take those, and then we first filter everything, because a bunch of those citations might not actually link to any website the model visited. And a bunch of those citations might also just be websites which don't work or don't exist. So we first have to kind of finesse the data, and our study puts aside the question, which a lot of the answers could be hallucinated, and if you have an hallucinated answer, there is no correct citation, right? So we're not looking into some of those trickier details, but at its core, we're getting it from the logs, and I provided the data sets and the paper in the chat, and so you can kind of see where we're getting the data from, and then what we're doing to the data.
Okay, so we rely on basically companies self-reporting essentially to be able to measure what's going on in the end.
Exactly, yeah. You're relying on the APIs, and then different companies having different standards for the API, which is, like you said, it's a great point. It's self-reporting, and there's no standardized API and standardized necessarily format for like what a log should look like in this situation.
I don't know, you'll all remember the Volkswagen emissions testing scandal. But at least the auto industry has a process and a way of legislating when to be fixing the results. What do you think about the context for this industry of having some kind of a way of having somebody that oversees and is charged with ensuring that you don't get similar, I'm being benchmarked against here, I'll put on a very, very fast process for this process, if you see what I mean. How do we fix that?
We actually wrote a blog post on this early on, but we don't actually, it's hard to verify for sure. I mean, we could assume they probably aren't cheating in changing their handwriting the answers or something. But the fact is that what happens when you call the API, they could technically just hook it up to anything. Like they could put calculators in the models, so we're really relying on their disclosure. And then there's also, of course, the question of if you're sending the benchmarks to the models, don't they now have the benchmarks? Which is also a problem. So I'd say benchmarking in general, it requires a lot of trust. And also just not training on the benchmark is another problem. I know a bunch of open source models have been having. It's definitely not a quick solution.
Yeah. I think it's an interesting question. I think again, I would say we need more emphasis on monitoring and post-model deployment rather than just the model itself, because we want to assess not just capabilities but behaviors, and we can only really know behaviors in the wild once it's got data, once it's personalized to a user. Like when OpenAI had this a reflection on how their model became too sycophantic, too overly agreeable to its users, this one model update. And they were like, oh, well, we didn't catch it because, in the tests, well, some benchmarks said it was too sycophantic, some said it wasn't. So, we just assumed that it was fine. And we didn't monitor it post-deployment. We don't have post-deployment monitoring to ensure our models are not overly sycophantic. Maybe because, incentivizes more usage. So maybe they like it. But I do think that post-deployment monitoring needs to feed into benchmark and benchmark relevancy, so that we know what are the right risks to look for. But then coming back to the meat of your question, as the economist in me, and Tim kind of often says that having third-party regulatory markets is vital. We can't just rely on scientists and the government to test, models or anything for harm, right? It's not the government who audits the books, the financials of a company, right? It's third parties who are empowered to do so because there are commonly agreed upon rules, and then there are also some sort of separation of powers that exist where an auditor audits a company, but in theory shouldn't be allowed to do business for that company. And through the invisible hand, the profit motive, things can go right, but it also means that there's an incentive to have a company audited, and those audits need to be relied on by other parties upstream and downstream, whether it's banks for providing loans to the companies. So trust is baked into the markets, and that, I think, compels everyone to do their job really well. And there's often scandals and frauds, but the third-party regulatory market that has arisen in something like banking and auditing, I think, that's ultimately what we need for AI, right? And that's why we need commonly agreed upon rules and standards. And already, talking about insurance, John mentioned insurance, there are already a lot of people providing insurance for these models. And even the model providers say that we're going to insure certain users, certain enterprise users of our services against legal challenge for copyright infringement. Because to encourage use, the enterprise user needs to know that these models, do what they say they will do, and do so in a way that's not going to open up the enterprise to legal liability, especially as governments adopt more AI and AI gets into the healthcare sector with confidential data. So I think trying to encourage the development of what Jack Clark and Gillian Hadfield call these third-party regulatory markets is, I think, vital. So the private sector at some point needs to get involved on the basis of publicly agreed upon standards, which we think is in the public interest.
And the problem here is that it's a global industry. And so, within any single jurisdiction, nobody's got the power to legislate for anything. So how do you create a regulator? You need something a bit like the Civil Aviation Authority, that regulates an international global system.
Yeah, that makes sense to me. And, just like with accounting standards, I think one first can push a national solution, a national approach to its limits. And then on that national basis, through national experiments, you can move up globally to see what works. Obviously, there's pros and cons with that approach. I think, it can be easier to first have national experiments and then push upwards. But I agree with you, these models are global, also in terms of energy usage, data, computing, where the compute comes from. Even if countries are trying to, lock it down and develop so-called national champions in some kind of imagined autarky, which I don't think is sensible.
Again, thank you, Ilan and Sruly. It was great conversation. And for everyone, thank you for joining. And please watch this space. We have exciting developments coming up that we will announce soon. So thank you and have a great rest of the day.